Hey everyone, and welcome. Today we're going to talk about something that gets right to the heart of mathematics, something we almost never even think to question. We're going to explore a really radical idea that challenges the very way we write down logic.
So let me just throw this out there. Imagine trying to do algebra or any kind of logic, but there's one huge rule. You can't use variables. No x, no y, none of them. I mean, it sounds basically impossible, doesn't it? Where would you even start?
For literally centuries, variables have been the absolute bread and butter of formal reasoning. You could say they're kind of like the nouns of mathematics. But what if? What if they aren't as critical as we've always assumed? What if there's a totally different way to say the same thing? That's the rabbit hole we're going down today.
To really get how wild this idea is, you have to appreciate just how baked in variables are. I mean, it's a universal convention, it's the default language we all learn. But a little while back, some pretty smart mathematicians started to wonder, could this language be better?
And it turns out all that questioning actually led somewhere. There is a powerful, totally rigorous alternative. A way to formalize all of set theory that just completely sidesteps the need for variables at all.
So this approach, it's a complete game changer. It's not just some clever little workaround, it's a fundamental reimagining of how set theory is built. The whole idea is to construct everything from the ground up without ever having to write something like, let x be an element of.
And look, this isn't just some obscure thought experiment. This is the real deal. It's the result of decades of work by two absolute giants in logic, Alfred Tarski and Tarski-Givant. In 1987, they published their huge work on it, laying out the entire system for the world.
Okay, so the big question is, how on earth does it work? If you don't have variables to stand in for objects, what do you use? Well, the answer is so elegant, it's beautiful. You just shift your entire focus.
This is the secret sauce right here. Instead of talking about some abstract things called x and y, and then saying how they're related, this system just starts with the relationship itself. The connections, the structures, that's the primary language.
Now, the engine that makes all this go is a mathematical toolkit called relation algebra. And you don't need to get bogged down in the jargon, but the key thing to know is that it gives mathematicians a set of rules, a kind of calculus, for working directly with relationships. You can combine them, flip them, transform them, all without ever needing to name the things being related. It's so cool.
All right, so this is a really fascinating idea, but you might be thinking, why does this matter now? Well, it turns out this isn't just some academic curiosity. This variable-free language has some very modern, very practical uses.
One of the best things about this system is that it's incredibly terse and concise. When you ditch the variables, the logical statements that you're left with are often way shorter and much more direct. And you know, that kind of efficiency isn't just pretty to look at. It's exactly what you want when you're working with computers. And you can see how one thing leads to the next here. Because the language is so clean and simple, it's absolutely perfect for mechanical manipulation. I mean, computers are amazing at applying fixed rules to symbols, and this whole framework is just tailor-made for that process. And that unlocks its potential for a super interesting field called interactive theorem proving, where people and computers team up to check really complex proofs.
And this is not just theory. The Tarski-Givant framework has been put to the test. It's been used successfully in actual experiments with automated theorem provers, showing that this seemingly abstract idea has some serious real-world computational muscle.
So what's the big takeaway here? By making this one single fundamental shift, by going from focusing on objects to focusing on the relations between them, Tarski and Givant didn't just find a neat party trick, they created a whole new, powerful, and incredibly efficient language for doing logic.
You know, it really makes you wonder, doesn't it? For so long, variables just seemed like a non-negotiable part of math. Seeing them stripped away so successfully really forces you to ask, what other rules that we take for granted, in math, in logic, maybe even in how we think, are just waiting for someone to come along and break them? What's next?